Good morning, students. In the last class, I started the second chapter of Module 5. There are four chapters are there in Module 5. Two chapters from textbook 2 and two chapters from textbook 1. So I have started the chapters from textbook 2. One chapter I already completed, that is chapter number 21, that is integration and component testing. And in the last class, I have started the second chapter, that is chapter number 22, that is system testing, acceptance, and regression testing. In the last class, I explained what is a system testing and also the comparison between system testing, acceptance testing, and the regression testing I have given. And when we are performing the system testing, acceptance testing, and regression testing, I also explained. And we are testing the system testing. We are performing for correctness and completion. Acceptance testing we are performing for usefulness and satisfaction. Whereas regression testing is performed to identify any accidental changes or the faults occur during the development of the product. So then the system testing will be tested by the development test group, whereas the acceptance test is done by the test group with the actual users who are going to use that system. And the last one, regression testing, is done by the development test group. System testing is said to be a verification. Regression testing is also a verification one, whereas the acceptance is said to be a validation. So that is these things I explained in the last class. Then I started with the system testing. I explained testing in detail. What is system testing? What are the characteristics of system testing? And then what is independence in system testing? How we can avoid the, or how we can achieve the independence, or how can avoid the independence, and what are the advantages and disadvantages of independence, I explained. And I explained about the independent verification and validation. Who will perform the verification and validation? Whether the verification and validation is performed within the organization or outside the organization. So if the verification and validation performs within the organization, what are the problem arises or what are the issues occurs, that I explained. And if we done the verification and validation outside the organization, then it is said to be a independent one. Or we can say that we are maximizing the independence by performing the verification and validation by the tester team which is outside the organization. So why we say that when we are performing the verification and validation independent, and if the verification and validation is done within the organization, then what happens? The people who involved in the development or the design phase, they may influence the testing team, and they uh, while influence, and they can get the result according to their expectation. So then we cannot achieve the maximum quality uh, through the verification validation where which is done within the organization. Hence, in order to avoid that, we are most of the organizations looking into the performance of verification and validation outside the organization. Means they will hire the team, or they can outsource the verification and validation process outside the organization. Okay, so when the persons who are outside the organization are performing the verification and validation, then we say that it is a independent verification and validation. Understood? When we say that the verification and validation is independent, if the verification and validation is performed by the people who are outside the organization, or who are outside the development organization, then we say that the verification and validation is independent. This also explained in the last class. And next one, I explained the independence without changing the staff. So here we are achieving the independence within the organization, but the perfect independence may not be attainable. But we can reduce the influence of the people who involved in design and development. And next, I explain the incremental system testing. So we performing the incremental testing throughout the system development, and incremental testing is performed to measure the progress. And here we are using the different test cases or system test suite to cover all the features and scenarios of the use. And as the progress project progresses, then the system passes more or more system tests. So here we are using the different test cases, and we'll see whether the system will pass the test or not. If the system passes the test, then we say that it is a successful. If the system fails the test, then we say that it is a failure of the system. Then we have to identify the reasons for failure. Then we have to check whether the faults occur or errors are there in the system that leads to the failure. And we need to identify such faults and errors, so that after correcting, once we identify the faults or the errors, we need to correct that in order to have the system for the correct operation. So I also explained the global properties of performance, latency, and reliability. These are called as the global properties. Why? Because we cannot measure the performance or the latency or the reliability at the beginning stage itself. So we can measure the performance, latency, and the reliability only when all the modules of the system are integrated and when the system start operating. So then only we can measure the performance, latency, and the reliability, and hence these three properties are treated as the global properties. Why we are calling as the performance, latency, and reliability as global properties? Yes, Gaurav Kote or Suraj? Hello, Suraj, connect ಆಗಿದ್ದೀರಾ ತಾನೆ? Hello.
Ma'am, yes, ma'am.
Tell me why the performance, latency, and reliability are said to be global properties.
Ma'am,
Yes. Yes.
uh, ma'am, it has a wide range of opportunity to.
Just now I said why they are called as global properties. ಕ್ಲಾಸ್ಗೆ ಸುಮ್ಮನೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಹೋಗ್ಬಿಡ್ತೀರಾ ಆಚೆ ಈಚೆ ಕೇಳಿಸ್ಕೊಳಲ್ವಾ ಕ್ಲಾಸು? Hmm? Just now I said why the performance, latency, and reliability are said to be global properties. So performance, latency, and reliability is said to be global properties because we cannot measure these properties during the initial stage of the system development. We can measure the performance, latency, and reliability once all the modules of the systems are integrated together and the system start operating. Then only we can measure the performance or the latency or the reliability of the system, and hence these three properties are treated as global properties. ಅರ್ಥ ಆಯ್ತಾ? So in the system testing, we are focusing on verifying the global properties against the actual system specifications. And here in the system testing, we are going to identify or we are going to find the unanticipated effects. That is, for example, is unexpected performance bottleneck. So, for example, when the system is installed and it is operating, suddenly something happens, then the system performance degrades. So it is the unexpected one, right? Such a type of performance is measured in the, or such a type of performance we are considering in the system testing. So we are mainly verifying the global properties against the actual system specification, and also we are going to find the unanticipated effects such as the unexpected performance bottleneck. So next I explain the context dependent properties. So here, some of the properties are depending on the system context and use. So if you consider the example of performance properties, here the performance property depends on the environment where actually the system is installed and also the configuration of the that particular system. So here depending on the environment or the configuration of the system, the performance of the system varies, and hence the performance is treated as the context dependent property. And one more is the privacy of the system. So the privacy of the users depends both on the system as well as how the system is used. For example, if you consider the medical records of the patients, they should be treated as very secured one. So if medical records are accessed by unauthorized users, then we must provide such unauthorized access. So means we need to protect the medical records so that we can achieve the privacy of the patients. Okay. So, because the medical records are the very critical or important records of the patients, that we cannot give it to somebody else, right? It is important one, and we need to protect such records. So, for that, we'll use the proper privacy measures and protect such records. So, privacy is also treated as the dependent, context dependent property. So next, establishing an operational envelope when a property is parameterized by use. For example, a request per second sent. So for example, when you are running the system or the program, then you are giving the input, right? How many your input you are giving per second, that it also depends. So that relates to the performance. So if you are entering the input slowly, then obviously the system performance decrease. Or as you enter more and more number of requests in a second, such that the system cannot handle those requests, then also the performance degrades. Or if you consider the size of the database, if the size of the database is small, then we can achieve better performance. As the size of the database increases, then at some point of time the performance degrades. Okay. uh, so hence these are also important in measuring the performance. And here we have to perform the stress testing by varying the parameters within the envelope near the bounds or behind the bounds. And next one is the goal. So what is a goal? A well understood model of how the property varies with the parameter that we are setting as a goal, right? Then whichever the parameter we are considering, we have to measure how sensitivity is that parameter, or is that property to the parameter, or where is the edge of the envelope, or what we can expect when the envelope is exceeded. These things we have to know. So because this also affect the system performance. So the next one is the stress requiring. The stress testing. So the stress testing requires the extensive simulation of the execution environment. Why? Because once we developed the system, we need to test that before releasing it to the market, or before giving it to the user, right? We have to perform the stress testing. And to perform the stress testing, we need to check the, or we need to vary the different parameters. So one such parameter is changing the number of requests. So suppose we are entering one request in a second, then what is the performance? Suppose if we are entering 10 requests in a second, what will be the performance? Or if we are entering more than 1,000 times of request, then what will be the performance? That we need to measure, right? Means by varying the values of the parameters, we have to measure the system performance, or we have to test the system, and that type of testing is called as the stress testing. And the main challenge for stress testing is it requires more resources. The resources may be in the form of human being, or the resources may be in the form of systems or the machines. Okay, because we have to give, or we have to enter more number of test cases, or we have to give more number of test cases to test the system. So to give the test cases, we need more human beings, or more machines are required. And the stress testing is not done regularly. Okay, it is not done regularly. it is running, the stress testing is performed in a very less manner, or less often we are performing the stress testing, and this stress testing is separate from the regular feature test, because regular feature test continuously we are performing, but the stress testing is the special type of testing that we are not performing continuously. Very less often we are conducting the stress testing, because it requires more resources in the form of human being, or in the form of systems or machines. And system testing diagnoses the deviations from the expectations, because see here, how the system is developed according to the given specifications, right? Sometimes what happens, some of the specifications are not met by the developed product, right? In order to test that, so in order to test the developed product, how much deviation exists from the obtained output with the given expectation, we need to measure that. To measure that, we are using the stress testing. Understood? Stress testing we are using to measure the deviation from the expectations. Okay, so because we are developing the product according to the given expectations, right? And our goal is that the system output must meet the user's expectations or the user specifications. If not, then we have to measure how much deviation is existing, or how much deviation has occurred. So to measure that, we are using the stress testing. And stress testing may also include the difficult debugging of latent faults. So, because we are using more number of test cases and more number of resources, then if was very less faults occurs, then identifying such faults is also difficult, and debugging those faults is also difficult. But that stress testing is includes that, even though it's a difficult task, but through the stress testing we are going to identify the latent faults, and we are going to debug or correct those faults. Next one is estimating the dependability. It is a measuring quality, but we are not searching for the faults. So it is fundamentally different goal than the systematic testing. So because we are mainly measuring the dependability, or we are mainly measuring the quality, not the faults. Okay, so hence it is different from the systematic testing. And quantitative dependability goals are statistical. So because here we are measuring the reliability, availability, and mean time failure. These properties I already explained in the previous class. What is reliability, availability, and mean time between the, or mean time to failures. So these that is the quality depends on these three parameters: reliability, availability, mean time between the failures, or mean time to failure. So if the system is reliable, then we say that the system is achieving more quality. If the system availability is more, then we say that it is the system is exhibiting the good quality. Or the mean time between the failure is more, then we say that the very less number of failures occur during the system operation, then we say that the system is exhibiting good quality. And the estimating dependability requires the valid statistical samples from the operational profile, because it is fundamentally different from the system testing. Uh, Next, we'll go for statistical testing. So to perform the statistical means, we to estimate the dependability, we need the statistical samples. And so if we need a valid operational profile or the model. And here this operational profile maybe sometimes it is from an older version of the system, or we are using the operational environment, or when we are performing the sensitivity testing, it reveals which parameters are most important and which are the parameters which are not important, and we can such parameters can be neglected. And so once we identify the parameters, then we can make use of it to perform the stress testing. And when we're using the statistical sampling, it requires the clear, precise definition of what is being measured. So we need to measure the failure rate per session or per hour or per operation. And like that, we can make use of many random samples so that we can to achieve the high reliability measures. So to achieve the high reliability measures, we can make use of more and more number of random samples. So when we are performing the statistical testing, we need to know whether the statistical testing is worthwhile or not. So the statistical this testing is very necessary for the critical systems such as the safety critical systems or for the infrastructure related systems. So for such systems, statistical testing is very necessary because these systems are treated as the critical systems. And performing the statistical testing is the difficult one, but it is not impossible. When it is difficult, when the operational profile is unavailable or it is just a guess, then no, if the new functionality involving the human operation or human interaction, then performing the statistical testing is difficult. But we may factor critical functions from overall use to obtain a good model of only the critical properties. And when we're performing the statistical testing, we are expecting the high reliability, or the high reliability requirement is very high in the statistical testing, because the statistical testing requires the more number of samples, or the sample size might require years of test execution, and we can achieve the ultra reliability with the statistical testing. Next, we'll move on to the process-based measures. And here, the process-based measures are less rigorous than the statistical testing, because these are based on the similarity with the prior projects. And the system testing, as I explained already, so here the system testing process expects the history of bugs found and resolved. And when we are performing the statistical testing, we can go for the alpha and beta testing. So in the alpha testing, real users and controlled environment are involved in testing the developed product. And for the beta testing, the once again the real users will be there, but there is an uncontrolled environment. See the difference between alpha testing and beta testing. In both the testing strategies, real users are involved, but the execution environment is controlled in the alpha testing and it is uncontrolled in the beta testing. And these alpha and beta testing may statistically requires the sample users rather than the users, and expected history of bug reports we can obtain through the alpha and beta testing. Also, the next one is the usability. Usability, as I explained in the previous class, that what is the acceptability, system testing, acceptance testing, regression, then what is the usability that I explained. So once again, we'll see in detail about the usability. So a usable product is quickly learned, allow user to work efficiently, and is pleasant to use. So if you consider an example of a mobile, so what type of mobile you are going to purchase? Whenever you are going to purchase the mobile, you are seeking for the usability. Means can we use that mobile in an easier manner or not? That is the very important factor that affects the sale, or we can say that that is the important product. It is playing a major role in the purchasing a particular product, right? So the product which is very easy to use, then the customers or more customers are going to buy it, right? And main objective criteria in usability is we need to know the how many number of operations we can perform in a given time. So time and number of operations to perform a task, and the frequency of user errors. So means when the users are using the product, how many errors occurs, or at what frequency the different errors occurs. So that also we need to consider. And so once the users are experiencing more number of errors when they're using the product, then they blame the entire product, right? Then the product is not going to be successful. So usability mainly relates to the overall and subjective satisfaction. Okay, overall user satisfaction or the subjective satisfaction. Then how we can verify the usability? So usability rests ultimately on testing with the real users. Means we are validating the product and we are not performing the verification there. So once if you consider an example of the mobile, so we can check the usability of the mobile. The usability of the mobile finally check when it is given to the users, actual users, or when it is released to the market. So then the users becomes the real users there. As the users are continuing using the mobile, then they give the feedback about that product. So there we are validating the product. We are not verifying the product. So usability rests ultimately on testing with the real users. And we can factor usability testing for process visibility, validation, and verification throughout the project. Obviously, whatever the product we are developing, we are performing the validation and verification throughout the project development. But finally, we are checking for the process visibility. Here, the validation establishes the criteria to be verified by testing, analysis, and inspection. So we'll see the factoring usability testing with respect to the validation and verification. Validation says about the usability lab, and verification by the developers and the testers. Usability testing established the usability checklist. For example, the guidelines applicable across a product line or the domain, whereas the inspection applies usability checklist to the specification and design. So here the usability, once it is means validation, with respect to the validation, we say that the usability testing established the usability checklist, whereas the verification here, the infection applies usability checks at the specification stage as well as at the design stage. Early usability testing evaluates cardboard prototype or markup because it produces the interface design, and behavior objectively verified against the interface testing. Interface design. So means here we are testing the design for the given objectives. So we have the different usability test criteria. One is exploratory testing. Second one is the comparison testing. Third one is the usability validation testing. And we'll see the exploratory testing. It is investigating the mental model of the users, and this exploratory testing is performed in the earlier stages to guide the interface design, whereas the comparison testing is for evaluating the options with respect to the specific interface design choices. And in the comparative testing, we are observing the interaction with alternative interaction patterns, or we are measuring the interaction with alternative interaction patterns. And the last usability testing is the usability validation testing. So by using this, we are assessing the overall usability or the quantitative or qualitative usability of the product. So it includes the measurements such as the error rate, time to complete. Rate means how many errors occurs during the system usage in a given time that we are going to measure, and time to complete means whenever the request is given to the system, how much time will it will take to complete that request, that we are going to measure. So validation testing includes these two parameters. One is the error rate, other one is the time to complete a given task. Next, typical usability test protocol. Here we are selecting the representative sample of user groups How we are selecting the user group? Typically, 3 to 5 users from each of one to four groups. So, if we have four groups, from each group we are selecting 3 to 5 users, and we are giving the set of questions or questionnaires to the users to verify the group membership. And here we are asking the users to perform a representative sequence of tasks. And when they are performing, then we are observing those outputs without interference or without helping the actual users. So, because we need to check the quality of the system and also the usability of the system. To do that, we are performing these tasks. But here, the hardest thing for developer is not to help. Professional usability testers use one-way mirrors, because if you're giving to the normal users, they don't know how to use that particular system. Then the problem arises. In order to avoid that, so initially the system is tested by the users who know how to use that particular system, and it measures the click or eye movement or the time, etc. And also we are following up with the different questionnaires or different questions. Next, we have the accessibility testing. So, accessibility testing checks the usability by the people with disabilities. So, for example, if the person who is blind or is having a low vision or is a deaf or color blinded person, so for such type of persons or users, we are going to give the system and we'll check the usability, that whether those physical disability persons can use that system without any problem. So then, because the accessibility is also important, because the normal users not only using the systems, other persons such as the persons who are having the disabilities, they are also using the system. We need to test the accessibility from that, from such type of persons. To do that, we are giving the systems to the blind or low vision or deaf or color blinded persons. So here, to perform this, we are using the accessibility guidelines, um, because a number of guidelines are available. We can use it. Here, direct usability testing with all relevant groups is usually impractical, and checking the compliance to guidelines is practical and often reveals the problems. One best example is W3C Web Content Accessibility Guidelines. Here, the parts of that accessibility can be checked automatically, and but along with automatic checking, manual checking is also required. For example, is the ALT tag of the image is meaningful or not? To test that, we can make use of the manuals. So next we are moving on to the regression testing. So what is regression testing? And we'll see that. So when we are building a new version of the system, so for example, by removing the faults or by changing or adding the functionality or by porting the system to a new platform or extending the interoperability, means we are changing the existing functionality in unintended ways. So when we are doing that, so sometimes even small changes can produce the unforeseen effects that lead to new failures. Because see here, when we are developing a new versions of the system, or when we are moving the system from one place to another, or when we are changing the environment of the system, then there may be a chance that the errors occur. If such errors may leads to the failure of the entire system, and such type of errors we need to identify, and that is called as the regression testing. Because see here, the system yesterday it was working but today it is not. So because one yesterday if error occurred, that is corrected, but today some other or some new error or faults may be occurring, and that may avoid the system operation. Then we need to identify such type of errors or faults. So for example, see here, I was fixing the fault X, and fixing the fault X means the fault X has occurred and that is corrected, and Next, we are accidentally broken the Y errors, or Y errors is accidentally occurred. Then if that is affecting the system performance, then we need to identify such type of errors and we need to correct those errors. Means that bug was fixed, but now it is back. So once even though the error is corrected and the system was working fine, but the error may occur once again, that may affect the system performance, that we need to check. So here, when in the regression testing, we need to perform the regression testing every time when there is any change in the system features or in the system itself. So test must be run, means a regression test must be rerun after any change. Any change means when we are adding the new features or changing or adapting the software to new conditions, or when we are fixing the other type of errors or other bugs. Then once it is fixed, once again we have to test the system. So that is called as the regression testing. Okay. And regression testing is a major cost of software maintenance, because sometimes it is much more than making the change. So continuously we have to perform the regression testing and we have to identify whether or what type of faults occur or not. Continuously we have to perform the regression testing. Hence the regression testing is the cost of regression testing is more when compared to other type of testing techniques. Then what are the problem arises in the regression testing, or what are the basic problems of regression testing? One is the maintaining the test suite or cost of retesting. So maintaining test suite, if I change the feature X, how many test cases must be revised because they use the feature X? Because for each feature, whether it is newly added or with it is removed, we have to use the different test cases to test that particular system. So we need more and more number of test cases or test suites. So maintaining those as test cases or test suite is a very complex task. And the next is which test case should be removed or replaced, because since it consisting of more and more number of test cases, and we cannot make use of all the test cases to perform the testing, and we need to check what which test cases we can replace, or which test cases we can remove from the test suite, or which test cases we need to add to perform the regression testing. Next is cost of retesting, because it's a the retesting is proportional to the product size. It is not change size. Okay. Because even if the product is small and if you're using more and more number of test cases, obviously the cost increases, that we need to look into. Next one is a big problem if testing requires the manual effort. So if we are performing the automatic testing, or by when we use the automatic tools for the testing, it is the cost will be less. But as we go for the manual testing, then we require the more number of human beings, and a possible problem even for automated testing, when the test suite and test execution time grows behind a few hours, then the problem arises. So next we have to maintain the test cases, because more number of test cases exist and maintaining such test cases is inevitable. Because see here, if future excess change, then we need to test or we need to modify the test cases, right? Then test cases for future X will require updating. Then some maintenance should be avoided. For example, trivial changes to user interface or file format should not invalidate large number of test cases. And the test suites should be modular one, because we need to avoid the unnecessary dependence, and generating the concrete test cases from the test case specifications can help in the test case maintenance. Obsolete and redundant. So we have to identify whether the test case is obsolete the test case or the redundant one. Obsolete means a test case that is not longer valid is called as the obsolete test case. Here the test features that have been modified, substituted or removed, because some of the test features which are not required, then such features can be modified, or to some extent we can remove those features. And once we remove the features, then the corresponding test cases should also be removed from the test suite. Next one is the redundant, a test case that does not differ significantly from others. Then such type of test cases should be treated as a redundant test cases. And here it is unlikely to find a fault missed by similar test cases, area some cost in re-execution error, some cost in human effort to maintain, and the redundant test cases may or may not be removed depending on the cost of the testing. Next is selecting and prioritizing the regression test cases. So this will check it. We'll continue it in the next class. Selecting and prioritizing the test cases, and one more topic is there. So if I'll cover that, that chapter will be completed. So selecting and prioritizing regression test cases, we'll see it in the next class. Any doubt in this, Suraj?
No, ma'am.
Okay, no doubt. I'll end my class.